guys, I'm Vaishali Kikan. Today we have moved to the next unit, which is the measurement and data processing. So we are going to start our discussion with the question which states calculate the change in temperature from the following data. So data is given, right? The value of the data is given and the uncertainty is given. Maximum temperature and the initial temperature is given in the degree Celsius. So maximum temperature's value is 57.58, uncertainty is plus minus 0.02. Initial temperature is 23.42 and the uncertainty is plus minus 0.02. So now we have to calculate the change in temperature. So we all know the change in temperature will be equal to the maximum temperature minus the initial temperature. What is the maximum temperature? If I see the actual value, it was 57.58 minus the initial temperature, its actual value was 23.42. So the change of temperature's value would be 34.16. Now we have to see the uncertainty. So uncertainty in the change of the temperature, what it would be? It would be the uncertainty in the maximum temperature plus the uncertainty in the initial temperature, which is 0.02 and 0.02. So we are going to add both of them. We have to add both of the uncertainties. So it will be equal to 0.04 degrees Celsius. So how I am going to write the change in temperature? 34.16 plus minus 0.04 degrees Celsius. So its maximum value would be 34.16 plus 0.04. So it would be 34.2. And now the minimum value would be 34.12, which is 34.16 minus 0.04, right? So it would be, the range would be 34.2 and the minimum value would be 34.12. So in this range, I will be getting the change of temperature. Other than that, how I am going to calculate the change in temperature? Change of temperature would be the maximum value of the final temperature. What would be the maximum value of the final temperature? If I see the final temperature, its maximum value would be 57.58 plus 0.02, which is 57.60, minus the minimum value of initial temperature. If I see the initial temperature, its minimum value would be 23.42 minus 0.02, that is 23.40. So I can take these two into consideration and I can get the upward range of the change of the temperature. Coming to the question number 2, which states what is the absolute uncertainty when 2.57 plus minus 0.01 is multiplied by 3.456 plus minus 0.007, and to how many significant figures should the answer be quoted? So we have to multiply two numbers with the uncertainty value. So first of all, I am going to take the actual value 2.57 and 3.456. I am going to multiply both of them. I am going to get 8.88.192. So 8.88192 is the multiplication of the actual numbers 2.57 and 3.456. Now the percentage uncertainties, it will be equal to the percentage uncertainty for the first number. What is the uncertainty? 0.01. What is the actual number? 2.57. So what is the percentage of uncertainty? 0.01 upon 2.57 multiplied with 100. So it is 0.39. Similarly, in the second case, 0.007 divided by 3.456 multiplied with 100, that is 0.2. So the total percentage of uncertainty is 0.39 plus 0.2, that is 0.59. That is the absolute uncertainty. Now absolute uncertainty can be found out by the total uncertainty, because we have taken the multiplication. So here we are going to multiply with the number 0.59 by 100 multiplied with 8.88192, which is going to give me 0.05. And you can see the uncertainty has two significant figures after the decimal. So I am going to represent the multiplication also with the two significant figures, that is 8.88. So the final answer would be 8.88 plus minus 0.05. Coming to the next question, weigh out accurately approximately 100 gram of water in a polystyrene cup, measure the initial temperature of water, weigh out accurately approximately 6 gram of potassium bromide, add the potassium bromide to the water, stir rapidly until it has dissolved and record the minimum temperature reached. Use the data below to work out the enthalpy change of solution to the appropriate number of significant figures, right? The mass of polystyrene cup in gram is 5.00 plus minus 0.01. Mass of polystyrene cup plus water in gram is 105.23 plus minus 0.01. Initial temperature of water in degree Celsius is 21.1 plus minus 0.1. Minimum temperature of water in degree Celsius is 19 plus minus 0.1. Now mass of weighing boat in gram is 0.5 plus minus 0.01. Mass of weighing boat plus potassium bromide in gram is 6.61 plus minus 0.01. Now we have to find out the enthalpy change, right? So we are going to work out with the masses, with the uncertainty. Now mass of water will be equal to 105.23 plus minus 0.01 minus 5.00 plus minus 0.01. So now what we are going to do, mass of polystyrene cup plus water minus the mass of polystyrene cup is going to give me the mass of water, so that I will be getting the mass of water equal to 100.23 plus minus 0.02 gram. Uncertainty, percentage of uncertainty of mass of water will be equal to, so what is the uncertainty? 0.02 divided by 100.23 multiplied with 100, that is 0.02 percentage. Similarly, percentage uncertainty of mass of KBr, right, potassium bromide is equal to 0.02 divided by 6.11 into 100, right? So you can see here we have the mass of KBr and the percentage uncertainty for the KBr, right? So mass of weighing boat plus potassium bromide is given, mass of weighing boat is given. So mass of potassium bromide will be equal to the mass of weighing boat plus potassium bromide minus the mass of weighing boat, that is 6.61 plus minus 0.01 minus 0.5 plus minus 0.01, that is 6.11 plus minus 0.02. So 0.02 divided by 6.11 multiplied with 100, that is 0.03. Now change in temperature of water will be equal to, so now you can see initial temperature of water and the minimum temperature of water is given. We can subtract them and we can get the change in temperature of water, which is 21.1 plus minus 0.1 minus 19.0 plus minus 0.1, that is 2.1 plus minus 0.2. So percentage uncertainty in the temperature change will be equal to 0.2 divided by 2.1 multiplied with 100, that is 9.5, which is the highest uncertainty. So I am going to take this as the uncertainty in the final answer, because this is the highest uncertainty, 9.5 percentage. Right, so heat taken in will be equal to mc delta T, right? This would be the enthalpy change, right? Mc delta T, C's value is 4.18, that we know. So m is 100.23, absolute value I am taking, and delta T is given, it is 2.1 absolute value. So heat taken in would be equal to 879.82 joule. So absolute uncertainty would be 9.5 percentage of 17.150. So it will be equal to 9.5 upon 100 multiplied with 17.15, that is 2 percentage, right? So enthalpy change will be equal to 17 plus minus 2 kilojoule per mole. So total percentage error will be the summation of all of them, 0.02, 0.03 and 9.5. So in this manner we will be getting the total percentage error. Coming to the next question, work out the index of hydrogen deficiency for C3H5N and suggest a possible structure for molecule. So what we have to do, we have to subtract 1 from the number of hydrogen atom given in the molecule. So hydrogen atoms are 5, we will be subtracting 1, so we are left out with C3H4. So the parallel alkane would be C3H8. Now how many hydrogens are less? 4 hydrogens are less. C3H4 has 4 hydrogen lesser than C3H8. So now I will be having 2 double bond. So equivalent index of hydrogen deficiency will be equal to 2. What would be the structural formula? We can have the structural formula CH3, CH2, C triple bond and or HC triple bond CH2, NH2. So these type of structural formula can be there. You can have many other structural formula as well. Coming to the next question. The infrared spectrum shown is for one of the compounds below. Identify the compound and explain your choice. This is the first compound, second, third and fourth compound. We have to choose which one is the correct. So you can see in the infrared spectrum that above 1500 centimeter inverse absorption band is present. So now the absorption band is present around 2840 to 3100 centimeter inverse, and due to which I can say that CH bond is present. Right? So another absorption band is present. So absorption band is present in 1700 to 1750 centimeter inverse, which is going to tell me that C double bond O bond is present. C double bond O, this bond is present. Now we have eliminated the option A and B because CH bond is present but C double bond O bond is not present in both A and B. Now the C and D options are left, and if I see this option C, the carboxylic acid has very broad OH absorption band in the 2400 to 3400 centimeter, which is not present in the given spectrum, right? So in the given infrared spectrum, there is no band in 2400 to 3400 centimeter, right? So I can say it is not even the option C. So the left out is the option D. Answer is D, as it contains CH as well as C double bond O, and it will be giving rise to a band in the region 1000 to 1300 centimeter inverse, because it contains C double bond O bond. Spectrum shows that there is absorption band in this region as well. So there is a confirmation that the answer is D. So I hope you understood all of the things that I have discussed. Thank you so much.